Good day everyone, Mr. Cargill here with our next AutoCAD video. Now for this video we're going to be looking at 30 multiple choice questions. This is the second video in which we're looking at technical drawing multiple choice questions. We already did a previous video where we looked at 30 questions, and today we're going to be looking at another 30 technical drawing multiple choice questions. So we'll start at number 31 here because we stopped at number 30 the last time. And in number 31 it says, the construction above shows how to draw a parallelogram equal in area to a given triangle. If EF is 30, then X is 15. So X would be B 15. And the reason for that is that X would be half of EF. Alright? So if EF is 30, that means that X is 15. So the answer is B 15. Alright. Number 32 says, the diagram above shows the method of finding the center of an arc with radius r, which is tangential to, and the answer would be B, tangential to lines meeting at any angle. Alright, so these two lines here, it doesn't matter what angle they are, this is how you would go about constructing a tangent to both those lines at any angle. Alright, so it's not to a straight line or a line and a circle or two lines meeting at right angles. Number 33 says, the diagram above is to be reproduced in third angle projection. On what views can the distance x be seen? Now the distance x can be seen from the plan view and from the side view in third angle projection. Because in third angle, the right will appear on the right and the left will appear on the right. Sorry, and the left will appear on the left. My bad. If it was first angle, the right would be on the left and the left would be on the right. But in third angle, sorry, the right stays on the right and the left stays on the left. So we'll see point x to x when you're looking from the right, and also when we're looking down, which would be the plan view. So the answer would be B, top and right side. Alright. Now here we have this figure, and it says that the sides of the square QRST above are bisected and the adjacent points are joined to form another square. The area of the new square is, so the area of the new square is going to be half the area of the previous square. Alright, because if you have a square and then you find the midpoint of all the lines, all four lines of the square, and you join those to get like a diamond, then that diamond or a square is going to be half the area of the larger square. Alright, so in this case, the large square, the area of the large square would be 18 times 18, which would be 324, and if you divide that by 2, you get 162. So the answer would be C, 162 millimeters squared. Alright. Item 35 says, in the diagram above, the circles and curves are shown in their true shapes. The method of projection used is, and the answer is A, oblique projection. Because in oblique projection, the front views of the figures will appear as is, and then the sides will slope at a 45-degree angle. So this right here is oblique projection. So the answer is A, oblique projection. For number 36, it says, in the ellipse above, this ellipse right here, which sum of distances is equal to AB? So this right here is AB. So is it F1C and F2C, or is it AC and then BC? Is it F2C, right here, F2C plus CD? Is it F1C, which is right here, F1C plus CB? And the answer here is F1C plus F2C. And this is also, this is it right here, F1C plus F2C. Because look at this here in AutoCAD. Alright, I'll go back to number 36 because AutoCAD is kind of loading right now. So I'll go back to number 36 once AutoCAD comes up, and I will explain why the answer would be F1C plus F2C. So for now, alright, AutoCAD came up. Alright, so here, this would be AB. Alright, and this is CD. So let's measure the length of AB. The length of AB is 120. The length of AB is 120. So if we should draw a circle here from point C here with the radius that is the same radius as AB, which is 120. Sorry, the radius would be 60 because the diameter would be 120. So the radius would be 60 and 120. So if I draw a circle from point C right there with a radius of 60, which is half of the 120, you would get this right here. Alright, so that would look like that. So what this point would be is F1, this point over here would be F2. So if I draw a line from F1 to C and draw a next line from F2 to C, this total distance should be 120, and we can look at that. So I should get two 60s. So from here to here should be 60, and right here it says it is 60. All right, and of course the next side is going to be 60 as well. From here, from this point, from here to here is going to be 60 as well. So that total distance will be equal to 120. Alright, so that's how the answer is equal to A. Alright, number 37. When dimensioning a new product, which type of drawing is usually made first? Is it a scale, a sketch, a detail, or an engineering? And the answer, of course, is a sketch. You always start out with your sketches. Number 38. The center of the circumscribing circle of a triangle can be found by using, and the answer is the bisector of any two sides. It should, let me see, number 38. Number 38 is indeed B, bisector of any two sides. If you have a triangle and you bisect any two sides, then you can get a circumscribing circle. So let me show you what that means exactly. Alright, so here I have a triangle, any triangle. I'm gonna turn off ortho. So I have a triangle. Alright, and I want to bisect two sides. So let me bisect two sides like this by just drawing a circle. Just copy this circle. You have to ensure that the circle is more than half the length of the line. Copy this circle from here, bring back circle here, and then just draw a line from this point here to that point right there. Alright, and then now let me just remove these circles. It's part of the construction, but it's going to get in the way. Alright, and I could bisect any other line, so let me just bisect this line as well. Let me just copy this circle from here, and if I draw a line like this, alright, I get that. So where those two lines meet, I should draw from the point where those two lines meet, then that circle should completely circle the triangle, touching each of the three sides but not going inside of the triangle. So just like that. So that's the circumscribing circle. This part is a little bit off because I think this point should have gone down a bit more, because I think I the circle from the wrong point because it meets up with this line here. But that's the idea. We get the circumscribing circle that will just go around the triangle, touching all three sides. Alright, so that is how we would arrive at our answer. The answer would be bisector of any two sides, which is B. Number 39. In a perspective drawing, all vertical lines have vanishing points. Oh, sorry. In a perspective drawing, all vertical lines, do they either A, have vanishing points, B, pierce the picture plane or towards the picture plane, D, are parallel to the picture plane? And the answer would be D. They'll be parallel to the picture plane. So number 39 here is indeed D, parallel to the picture plane. And that is what we mean by parallel to the picture plane. Alright, so let me show you what we mean by that. So if I have a square, let me just use this. So if I have a square or a rectangle like this, all right, and this point, center, would be where all the vanishing points would go to on my picture plane. All right, so I know this kind of looks like just with two diagonal lines, but don't picture it like that. Picture it as like an image. All right, an image, like this is like a road or something like that. This is like the sky, and then you know this is like the side of the road and stuff like that. So over here with the picture plane, all right, so vertical lines will be parallel to the picture plane. So these vertical lines here represent where the picture plane is. So if I should draw a vertical line from here down to here, like that, or from here down, something like that. Those lines would be parallel to the picture plane, because right here you can see we have the picture plane here, and then these two lines here are parallel to the picture plane. All right, so that's what we mean by that. So the answer would be D. They will be parallel to the picture plane. All right, number 40. It says the number 40 refers to the following diagram. So this diagram right here. It says the diagram above shows a method of constructing is it A, tangent to a circle at a point? Is it B, tangent at a point on an arc? Is it C, circle passing through a given point? Is it D, circle tangential to two converging lines? Alright, so for number 40, the answer is B. Alright, so the answer is B. And B says tangent to a point on an arc. So this is our arc right here. This is the point on the arc, and we're trying to construct a tangent to that point on the arc. Alright, so the answer would be B. Number 41. Which of the following scales would be used to produce the smallest drawing of a given object? Is it 1 to 2? Is it 1 to 1? Is it 5 to 1? Or is it 10 to 1? It says which of the following scales would be used to produce the smallest drawing of a given object? And the answer would be 1 to 2, drawing it half the size. Number 41, yeah, A. 1 to 2, drawing it half the size. 1 to 1 is the exact size, and 5 to 1 and 10 to 1 is actually bigger than the actual figure. So yeah. Alright, here it says item 42 refers to the following figure. It says the figure above illustrates the start of a method of construction for drawing views of. Is it A, circles in perspective drawing, B, circles in isometric drawing, irregular curves in perspective drawing, irregular curves in orthographic drawings? And answer would be B, circles in isometric drawing. So let me show you. So here, let me turn on the isometric grid. So let's say I had this. Let me switch to, yeah. So if I have this box here, let's make this like 40 by 40 or something. Alright, so if I have that isometric box right there, which would be like this isometric box right here. So if I should do this, if I was to draw a line from here to this center line here. The center of that line, sorry, not center line, but the center of the line. And from there to the center of this line. Also from here to the center of this line, which would be here. And from here to the center of this line, which would be right there. Alright, so now from here I would be able to draw an isometric circle. I would be able to draw an isometric circle by doing this. Alright, if I do this, let's say I draw a circle from there to right there, and then draw a next circle from this point here to this point right here, and a circle from here to this line here, and then from here to this point here, I would get my isometric circle. So let me trim and show you my isometric circle. So if I trim that, trim this, if I trim this, trim all of these, this and this, trim this. Sorry, not the box, I didn't mean to trim the box. Trim that, this. Yeah, and there I would have my isometric circle. Alright, so that's my isometric circle. So that is why the answer would be B, circles in isometric drawing. Alright, so we move on to number 43. Number 43 says, which of the following drawings represents a truncated prism? No, the term truncated means that a piece of it is cut off, and the answer is A. Alright, number 43, let's see. 43 is A. And the reason, and how we know that is because you see these hatching lines, and what those hatching lines represent is where a cut is made. Alright, so that is why you would have those hatching lines there to represent that a cut was made in that area. Good. Alright, number 44. On which of the following planes would the plan of an orthographic projection appear? It says, on which of the following planes would the plan of an orthographic projection appear? Is it the profile plane, vertical plane, auxiliary plane, or horizontal plane? It should be the horizontal plane. So number 44, let's see. It is D, the horizontal plane. And what that means is that we would have a isometric. Yeah, so if we have a line here, so we have a horizontal line and we have a vertical line. Alright, so the plan view, in your drawing plan view, it will be either above or below the horizontal plane. Alright, so that's that means. Good. Now, number 45. So which of the following class of fire extinguishers can be used to put out an electrical fire? Should be class C. Let me see. Number 45, C. Yeah, number 45, C. Class C fire extinguishers are used to put out electrical fires. Number 46 refers to the following diagram. It says, in the diagram above, two arcs are drawn tangentially to two circles of different radii. What are the lengths of EX and CY respectively? So what are the lengths of EX and the length of CY? Now, for EX, alright, which would be right here, we have this arc here. So it says for EX and for CY. Number 46 is A, and A is 75 and 80. Alright, so here we have this arc, and the radius of this arc is 55. Alright, and we have this arc right here, and the radius is 110. Okay, so what we're going to do here is we are going to subtract the radius of this circle from the radius of this arc right here. All right, and the radius of the arc right there is 110. All right, and then the radius for the circle is 70. Sorry, the diameter for the circle is 70, which means that the radius would be 45. So if we minus 45 from 110, we will get, sorry, it's not 45, it's 35. Because 70 divided by 2 is 35, yeah. So it's 110 minus 35 equals 75. And then for the next one, the arc is 55 and the circle has a diameter of 50. And for that one, we're going to add. So what we're going to do is to add 55 to the radius, which would be 25, since the diameter is 50, that gives us 80. And that's how we end up with 75 and 80 for EX and CY. And the reason why we subtract for over here for EX is because EX is an external tangent, and when we have an external tangent to two circles, we will subtract the radius. All right, and when we have an internal tangent, because this tangent right here is an internal tangent, we will add. So we add the 55 to the 25 and we subtract the 35 from the 110, and that's how we end up with 75 and 80. All right, number 47 says the distance between the foci of an ellipse is 24 millimeters and the length of its minor axis is 18 millimeters. The length of its major axis in millimeters would be, all right, so let's see. It says that the distance between the foci of an ellipse is 24 millimeters and the length of its minor axis is 18 millimeters. The length of the major axis in millimeters would be number 47. The answer for that would be C. And it says 30. And how we would go about getting that, it would be similar to what we have here when we did the ellipse. All right, we have the major axis and stuff like that, and all of that stuff. So using that, we can figure out what the length of the major axis would be. All right, so let me see, what does it say that it says that the minor axis is 18. All right, so the minor axis is 18. All right, and then the distance between the foci would be 24. Okay, all right, so we can figure out that. So if this is 18, let's draw this line. This is the minor axis. This is 18 here, and the distance between the two focal points would be 24. So this would be 12 in this direction, and then 12 in this direction. All right. So what that means, therefore, is that if we did this, we draw a line from there, and then draw the next line from here, and then measure those. Let me see. If we measure both those lines, (15). See that? So it says right here that this is 15. So if that is 15, it would mean that therefore this over here would also be 15, and 15 plus 15 gives us 30. Alright, so 15 plus 15 gives us 30. So the distance would be 30. Alright, so that's how we would go about working that out. Good. So C, 30. Nice. Alright. Number 48. The tolerance for a shaft 18 millimeters long is plus 0.055 and minus 0.063. What is the correct tolerance range? The correct tolerance range would have to be 18.055 to 17.937. All right. So what when we talk about tolerance, we're talking about, you know, like an acceptable range. And if the acceptable range in this case is plus 0.055 and minus 0.063, then we'd have to add 0.055 to 18 and subtract 0.063 from 18, and then in that range right there, that would be the acceptable range. So in this case, the answer would be C, 18.055 to 17.937. Number 49. Three circles of varying diameters which touch one another can be drawn if given. Number 49. Number 49. B. 49 is B. Two lines and a point. Yeah. So if you have two lines and a point, then you can draw. You'll be able to draw three circles of varying diameter which touch each other. And this is how. If I have a line, let me turn off. So I have a line there, and I have a next line. Let's say somewhere like there or something like that. I'll draw a circle here. Alright, then I could draw a circle that would touch this circle depending on the diameter of this circle and stuff like that. And if I'm given the next point, I would be able to draw the three circles that would touch each other. Alright, so here, number 50. It says RS is a straight line, sorry. A line segment 25 millimeters long is marked. Exterior angles of 45 degrees are marked off at each end of the line segment. The two angled lines formed are 25 millimeters long. If this construction is continued until a closed figure is formed, the figure obtained is, what would the figure be? So you have a straight line, a line segment, marked off, exterior angles of 45 degrees. That should be an hexagon. Let me see, number 50 would be an octagon. Alright, so if we have a straight line, or a line segment 25 millimeters long marked, and you have exterior angles of 45, 45 times 8. Yeah, so the answer would be an octagon in that scenario. Alright, and the reason why it would be an octagon is because if you do 45 times 8, you would get 360. And you know, an octagon has 8 sides, hence 8 angles are 45, and you would end up getting an octagon. Alright. Item 51 refers to the following drawing. It says, the diagram above shows the development of a pentagonal box with a lid, hexagonal box with a lid, pentagonal box without a lid, or an hexagonal box without a lid. And the answer would be a hexagonal box with a lid. So we know it's a hexagon because it has 1, 2, 3, 4, 5, 6 sides, and then it has a lid because we see the lid right here, and even the lid shows that it's an hexagon. Alright, so the answer is B. Number 52 refers to the following elevations. The elevations shown above are those of a square prism, square pyramid, triangular prism, hexagonal prism. The answer would be a square pyramid, but let me see. Number 52 is D, a hexagonal pyramid. The reason why it's an hexagonal pyramid, we're seeing 3 sides here, and if you're seeing 3 sides in one view, it has to be a hexagon, because that means that the next 3 sides is in the next view. Alright, so that's the reason. Alright, number 53. When a plane figure has a linear reduction, just a linear reduction. Proportions are changed, proportions remain the same, dimensions remain the same, dimensions and proportions are changed. The proportions remain the same. Number 53 is an enlargement and reduction question. So number 53, B, and B says that the proportions remain the same. Alright, so the dimensions will change because it will get larger or smaller. Oh, it says reduction. So it will get smaller, but so the dimensions will change, the dimensions will get smaller, but the proportions will remain the same. So if it's like a triangle, and let's say you're scaling, let's say you have a triangle with sides of 15, 9, and 12. And then you can scale it down to get 3, 4, 5. So the proportions remain the same, but the dimensions get smaller. Which of the following represents an inscribed or ascribed triangle? It's circle. It would be a circle that touches a triangle at one point, at one line, just one line of the triangle. So that would be A. So number 54 would be A. So this, it touches the triangle just at one side. Alright? Good. Number 55. Which is the first step that should be taken if a person receives an electric shock in a workshop? Is it turn off the power source, activate the fire alarm, remove the person safely, cover the person with a safety blanket? The answer, surprisingly, is going to be B. Number 55, let me see. Yeah, B. Activate the fire alarm. And this is the reason. You might say that the answer is to turn off the source. Alright? But what if the source is the reason for the person, you know, getting an electrical shock? What if it's like a breaker panel or something like that? You know, and that is the main source that you can turn off. So you can't try to turn that off because you'll end up getting shocked as well. And you don't know if anything is live or whatever. So what you have to do is just activate the fire alarm and get help. That's as most as you can do in that situation. And you cannot remove the person. Because if you touch someone who's been electrocuted, you know that ends. Alright, number 56 says, in the drawing above, which of the following is not true? Is it A, the line RM is equal to the line PR? RM is equal to PR. Is it the line DR can be of any length? DR can be of any length. The angle PRM is equal to the angle RPM. PRM, RPM. Yeah, that's not true. The angle RPM is equal to the angle RP. Angle RMP is equal to RPM. RMP is equal to RPM. Let me see. Number 56. The answer is C. Yeah, the angle PRM is equal to the angle RPM here. That's not right because this angle right here, PRM, you can see that this angle is wider than RPM. Alright, so yeah. Number 57. A netball court has a length of 30 meters. A line representing this distance on a drawing measures 30 millimeters. So what scale ratio is the line drawn? 1 to 1000, right? 1000 millimeters make a meter. So number 57 would be, yeah, A. 1 to 1000. Since 1 meter on the drawing would be represented by 1 millimeter. Alright, so, and 1000 millimeters makes a meter. So it will be 1 to 1000. Number 58 says, which of the following is true of the drawing above? The triangle EGH, the triangle EGH has been enlarged to a figure which is twice its area. No. The quadrilateral EFGH has been reduced to a figure having half of its area. The triangle EGH are equal in area. And C. This triangle EGH and FGH are equal in area. Once the triangles have the same base and the same height, they're going to be equal in area. Alright, so the answer would be C. The triangles are equal in area. Number 59 says, which of the following drawings indicate the correct method of constructing similar triangles? Alright, constructing similar triangles. The answer should be C. Let me say number 59 is indeed C. Alright, similar triangles. So the proportions will be the same, but it's just reduced. The proportions will be the same, but the scales would be different. Right? The lengths of the lines would be different, but the proportions would be the same. So the answer would be C. Then number 60, the last question. The figures above show 3 views of a block. The front elevation, end view, and the plan respectively are front, end, and plan. Okay, so the answer would be front, end, and plan. So let's work out what is what. Oh yeah, so the front would be, let me see. Okay, so the front would be 2, the end would be 3, and then the plan view would be 1. Yeah, so 2, 3, 1, which would be C. So number 6, it should be C. Yeah, which it is. All right, good. So we are done with our next 30 multiple choice questions. I hope that you found this helpful, and if you did, you could drop a like and also subscribe to the channel. We are very close to reaching 1,000 subscribers. All right, so thank you all for the continued support, and do have yourselves a wonderful day.